Troubleshooting in AWS, GCP, Azure, and Kubernetes. Troubleshooting in cloud environments is a critical skill for developers, DevOps engineers, and system administrators. Whether you're working with AWS, Google Cloud Platform, Azure, or Kubernetes, understanding how to diagnose and resolve issues efficiently is essential to maintaining reliable systems and minimizing downtime. In this chapter, we'll explore practical ways to test connections to cloud resources such as databases and storage, and we'll discuss how to investigate container crashes and other common types of errors. Let's start with testing connections to resources in the cloud. When dealing with AWS, one of the most basic tools for testing connectivity is the telnet or NC command. If you're trying to connect to an RDS database, for example, you can run telnet RDS endpoint 3306 to check if the port is open. You can also use curl or ping to check connectivity to services like S3 or EC2 instances. Additionally, AWS CloudWatch logs can be invaluable for debugging permission errors, timeouts, or misconfigurations. Using the AWS CLI, commands like AWS S3LS or AWS EC2 describe instances can help confirm both connectivity and credential configurations. In Google Cloud Platform, or GCP, similar strategies apply. Use cloud commands such as gcloud SQL connect instance name user equals root to test database connections. For cloud storage, try using gsutil lsgs:// your bucket name to confirm that your permissions and network paths are valid. VPC firewall rules in GCP can sometimes block traffic unexpectedly, so always review firewall rules if you encounter connection problems. Stackdriver logging, now known as cloud logging, provides granular insight into operations, errors, and system performance. For Azure, the Oz command line tool offers ways to verify connectivity and resource availability. You might run Oz SQL DB list or Oz storage blob list to check access to databases and storage accounts. Azure Network Watcher is an excellent resource for troubleshooting network-related issues, such as IP flow verification or connection monitoring. For example, you can simulate traffic from one VM to another and identify where the communication is blocked. Always verify role-based access control, or RBAC, settings, as these often cause unexpected denials or timeouts in Azure environments. Now, let's talk about troubleshooting in Kubernetes, a powerful container orchestration system used across all three cloud providers and on-premises environments. One of the first steps when a container fails is to use the kubectl command line tool. Running kubectl get pods will show the status of your pods, and kubectl describe pod name will provide detailed information about the events leading up to the crash. If a container has crashed, use kubectl logs pod name to view the standard output and error logs. This often reveals application-level errors, such as failed database connections, misconfigurations, or unhandled exceptions. Sometimes, the error message will say crash loop back off, indicating that the container keeps failing and restarting. This is commonly due to configuration errors, missing environment variables, or failure to connect to dependent services. Use kubectl exec pod name /bin/sh to start a shell session inside a running container and manually inspect logs, environment variables, or file system paths. For more advanced debugging, enable Kubernetes auditing or integrate with observability tools like Prometheus and Grafana to monitor resource usage and spot performance bottlenecks. If the issue is network-related, tools like kubeproxy, netshoot, or kubectl port forward can be helpful in simulating network traffic and isolating communication problems. Containers in Kubernetes can also fail to start due to image pull errors, which are often caused by incorrect image names, unavailable container registries, or authentication issues. Kubernetes events and logs will usually provide clues such as image pull back off or error image pull. If you see these, verify that your image repository is accessible and that credentials, if required, are configured correctly using image pull secrets. To wrap up, successful troubleshooting in the cloud and in Kubernetes is about asking the right questions. Can I connect to the resource? Are permissions configured correctly? Is the network allowing traffic? Is the application inside the container behaving as expected? By methodically testing each piece, starting from the infrastructure and working up to the application layer, you can isolate the issue and resolve it quickly. Remember, cloud environments provide powerful logging, monitoring, and debugging tools. Whether you're using AWS CloudWatch, GCP Cloud Logging, or Azure Monitor, always take advantage of these tools to get deep visibility into your applications and infrastructure. Mastering troubleshooting is not just about knowing the tools, it's about thinking like a detective, following the clues, and testing your assumptions step by step. This concludes our chapter on troubleshooting in AWS, GCP, Azure, and Kubernetes. In the next chapter, we'll explore how to set up automated monitoring and alerting to detect and resolve issues before they become major problems.